Algebra 2, Chapter 4, Section 5. This lesson we're going to learn about 2 by 2 matrices, determinants, and inverses. Okay, so what are we going to learn? We're going to learn how to evaluate determinants of a 2 by 2 matrices and find the inverses. Okay, we're then going to go further into it and use those inverses to solve matrix equations. So, first thing, a square matrix is a matrix with the same number of rows and columns. For any real number a, the number 1 is the multiplicative identity of a, since a times 1 is equal to 1 times a, which is a. Square matrices also have a multiplicative identity. All right. For an n by n square matrix, the multiplicative identity matrix is an n by n matrix or a square matrix with ones along the main diagonals and zeros everywhere else. So here's the identity matrix for a 2 by 2. Here's the identity matrix for a 3 by 3, so on and so forth. If the product of a real number a and b is 1, and a and b are considered multiplicative inverses, some, but not all square matrices have multiplicative inverses. The multiplicative inverse of a matrix is this. If a and x are n by n matrices, a times x equals x times a, which equals I. That's the one with the zeros everywhere and ones down the diagonal. Then x is a multiplicative inverse of a, written a negative 1, or a inverse. So matrix A times its inverse is the same thing as its inverse times a. Well, the result is the identity matrix. Okay? If B is the multiplicative inverse of A, then A is the multiplicative inverse of B. To show that A and B are multiplicative inverses, all you have to do is show that A times B equals I, or that B times A equals I. So now that we've kind of covered that, let's go on to the lesson and see how we can solve these matrices. Okay, show that matrix B is a multiplicative inverse of A. All we have to do is then multiply the two matrices. So let's just look. So we just got to multiply matrix B by matrix A, which is going to be 2 times matrix B is 2, negative 3, negative 1, 2. And we're going to multiply it by matrix A, which is 2, 3, 1, 2. Okay, so let's just multiply our matrices. It's a 2 by 2 matrix times a 2 by 2 matrix. So we can do it, and we're going to just get a new 2 by 2 matrix. So let's just set it equal and see what happens. First row times first column. We're going to get 2 times 2 plus negative 3 times 1. Okay? We do the math real quick on that. That's 4 minus 3, so that'd be 1. So we know we're still in the ballpark here. All right, first row, second column. 2 times 3 plus negative 3 times 2. So that's going to be 6 minus 6. So that's going to be 0. So we're good. All right, now let's go second row, first column. We're going to go negative 1 times 2 plus 2 times 1. So we're going to get negative 2 plus 2, which is 0. So we're still good. Second row times last column. Negative 1 times 3. Negative 1 times 3 plus 2 times 2. 2 times 2. So that's going to be negative 3 plus 4, which is 1. So I have a new matrix. When I multiplied matrix B times A, I get 1, 0, 0, 1. So that's the multiplicative inverse. That's the inverse, the identity matrix of a 2 by 2 matrix. So A times B equals that. So we know B is the multiplicative inverse of A, and A is the multiplicative inverse of B. Okay? So every square matrix with real number elements has real number determinants. Okay, determinants is an easier way for us to find the inverses. So how can we find the determinant? All right, so for a 2 by 2 matrix, matrix A has elements A, B, C, D. So to find the determinants of a matrix, we would write determinant A is nothing of A, B, C, D is going to be nothing more than the cross multiplication of AD minus BC. So the determinant of A is nothing more than AD minus BC. And this determinant, we're going to learn in just a second, it's going to help us find the inverses a little bit quicker. So find the determinants of each matrix. So looking at A, the determinant of -3, 2, 4, -5 is going to be -3 times -5 minus 4 times 2, which is going to be equal 15 minus 8, which is going to be equal to 7. All right. Part B, the determinant of 2, -3, 3, -2. That's just going to be 2 times -2 minus -3 times 3. So that's going to be -4 minus -9, which would be -4 plus 9, which would be 5. Okay, the last example is using variables. So the last example is the determinant of AOA. So that's going to be A squared minus O, which is going to be A squared. Okay, so we have a good feel on how to find determinants of a 2 by 2 matrix. Okay, so let's keep going on. So to evaluate the determinant of this matrix, so this would be 4 times 2 minus 2 times 4, which would be 8 minus 8, which would be 0. Okay, next one. That would be 8 times 3 minus 7 times 2. So that would be 24 minus 14. So that would equal 10. Okay, here we go. This one would just be K times -3 minus 3 times 3 minus K. So that would be -3K minus 9 plus 3K. 3Ks will cancel. So the answer would be -9. Okay. So the following test will help you determine whether a 2 by 2 matrix has an inverse. It'll also help you find the inverse. Okay. If A is a 2 by 2 matrix and the determinant does not equal the determinant does not equal 0, then A has an inverse. Okay, if the determinant A does not equal 0, then the inverse of A is this. 1 over the determinant of A times that matrix, but we're going to flip some spots. We're going to flip the D and A spot. And we're going to make B and C negatives. Okay? And if you remember, the determinant is just AD minus BC. So write that down. This is important to know. The inverse is 1 over the determinant of the matrix times a matrix that's been kind of modified, dA negative B negative C. Okay, so let's look at that one. Determine whether each matrix has an inverse. So here's our matrix that's given. Matrix is negative 2, 2, 5, negative 4. So the first thing we're going to do is we're going to find the determinant of M, which is going to be negative 2, 2, 5, negative 4. So that's going to yield negative 2 times negative 4 minus 5 times 2. So that's going to be 8 minus 10. So the determinant is negative 2. So the determinant of M is negative 2. Well, so it does have an inverse. The inverse is 1 over the determinant times, if you remember, it's going to be D negative B negative C A. So let's plug in everything we know. So the inverse is 1 over negative 2 times our D value, which is negative 4. Our negative B value would be negative 2. Our negative C value would be negative 5. And our A value, negative 2. Okay. So now our multiplicative inverse, we're just going to multiply by the scalar of negative 1/2. So that's going to become negative 4 times negative 1/2 would be 2. Negative 2 times negative 1/2 would be 1. 5 times negative 1/2 would be 2.5. Negative 2 divided by negative 1/2 would be, or multiplied by negative 1/2 would be 1. So my inverse, not my inverse, but yeah, my inverse matrix would be 2, 1, 2.51. All right, next example. So I have a matrix N of 3, 9, 2, N. So the determinant of N would be 3 times 6 minus 9 times 2. 3 times 6 is 18 minus 9 times 2 is 18. So my determinant N is 0. So no inverse exists. Okay. Determine whether this matrix has an inverse. So our matrix, so we're going to find the determinant of this matrix. We'll just call it the determinant of M of 2, 4, 1, 3. So the determinant is going to be a product of the cross multiplication. So 2 times 3 I don't know why that's not working. Let's do it again. 2 times 3 minus 4 times 1. So that's going to be 6 minus 4. So the determinant of that matrix is 2. So yes, it does have an inverse. So the inverse of that matrix is going to be 1 over the determinant D negative B negative C A. So let's just plug in our values. Our determinant's 2, so it's just going to be 1/2 times our D value's 3, our negative B value is negative 4, our negative C value would be negative 1, and our A value is 2. So we're going to multiply, so that's going to be 1.5 negative 2 negative 0.5,